The Romans built nanotechnology. Not by accident. On purpose. This cup changes color like a chameleon, and scientists spent decades assuming it was impossible. Until electron microscopes revealed particles smaller than a wavelength of light, precision we only achieved in the 1990s. Here is how 4th century craftsmen mastered technology 1600 years before we even knew it existed. In 1958, the British Museum acquired what appeared to be a beautiful but unremarkable Roman cage cup. The carved scene depicted King Lycurgus being strangled by vines, a punishment from the god Dionysus. Curators placed it in storage. It sat there for years before anyone noticed something extraordinary. When a researcher moved it near a window, the cup transformed. In reflected light, it glowed jade green. But when sunlight passed through it, the glass turned the color of fresh blood. No other ancient glass behaved this way. No medieval glass. Nothing until modern fiber optics. The museum had accidentally acquired the most technologically advanced object from the ancient world. But the real question would take another 30 years to answer. How did Roman craftsmen create optical nanotechnology in the 4th century? And perhaps more troubling, did they actually understand what they had created? The first scientists to examine the cup assumed the color change was a trick of the light. Perhaps a coating. Perhaps unusual mineral content. They were wrong. In 1990, researchers finally had access to transmission electron microscopes powerful enough to see what was hidden inside the glass. What they found defied explanation. Embedded throughout the cup were particles of gold and silver, each measuring approximately 50 to 100 nanometers in diameter. To understand how small that is, consider this. A human hair is 80,000 nanometers wide. These particles were smaller than a wavelength of visible light. This was not decoration. This was engineering at a scale that seemed impossible for any pre-industrial civilization. The scientific community was stunned. But here is where it gets truly strange. The ratio of gold to silver was not random. It was precisely calibrated. 7 parts silver to 3 parts gold. And this specific ratio is exactly what modern physicists calculate is needed to produce this optical effect. The Romans had not stumbled onto this by accident. Let me put this in perspective. Pause, the science behind the Lycurgus cup has a name. Plasmon resonance. When light hits metal nanoparticles, free electrons on the particle's surface oscillate collectively. Different wavelengths get absorbed or reflected depending on particle size and composition. Green light reflects. Red light passes through. This is the same physics that modern engineers use to create biosensors, cancer detection devices, and quantum computing components. We consider this cutting-edge technology. Papers are still being published about it. Yet here was a Roman artisan achieving the same effect 17 centuries earlier. But wait. How do you manipulate particles you cannot see? The Romans had no microscopes. No knowledge of electrons or quantum physics. No periodic table. They did not even have clear glass consistently until the 1st century. So how did they create precision at a scale completely invisible to them? The answer lies not in what they knew, but in what they did. Roman glassmaking was an industrial operation. Workshops across the empire produced millions of vessels. Most were utilitarian. But a specialized class of artisans created luxury items for the wealthy elite. Cage cups like the Lycurgus cup required extraordinary skill. The outer cage was carved from a single solid piece, leaving just thin bridges connecting the decorative shell to the inner vessel. One mistake meant starting over. These craftsmen were perfectionists. And they kept detailed records of their recipes. Here is what we know they added to this particular batch. Gold, silver, and something else. The analysis revealed traces of metals that should not be there. Antimony, manganese, even traces of lead. This was not contamination. This was deliberate. Roman metallurgists understood that adding specific metals to their alloys changed their properties. Color, hardness, melting point. They were empirical chemists, testing combinations over generations, recording what worked, discarding what failed. The nanoparticles were not planned. They were a side effect of a recipe refined over centuries. But here is what nobody expected. Pause. In 2007, researchers at the University of Illinois decided to recreate the Lycurgus Cup effect. Not study it. Recreate it. They followed every Roman technique they could document. They mixed gold and silver in the 7:3 ratio. They added the trace metals. They fired the glass at Roman temperatures. And it worked. But that is not the revelation. When they tested their recreated glass, they discovered it was not just visually identical to the original. It was functionally superior. Their modern recreation, using only Roman methods, outperformed glass made with contemporary nanotechnology techniques in certain optical applications. Let me say that again. Direct address, using Bronze Age furnaces, clay crucibles, and recipes written in Latin, these researchers created nanoparticles more uniform than machines could produce. The Romans had not stumbled onto this technology. They had optimized it through generations of trial and error, achieving results our computerized processes still struggle to match. This raises a profound question about technological progress. We assume advancement is linear. That we know more than those before us. That our machines always outperform their hands. But the Lycurgus Cup proves this assumption wrong. Consider what the Roman craftsmen had. Thousands of hours of practice. Recipes passed down through generations of masters. An economic system that valued quality over speed. Lifetimes of subtle adjustments that no one wrote down because they seemed obvious. Tacit knowledge, embedded in muscle memory and trained intuition. Now consider what we have. Precise instruments. Computer modeling. Atomic level control. Yet we lack something the Romans possessed. Time. Patience. The willingness to spend decades perfecting a single process. Our optimization happens in months. Theirs happened over centuries. And in certain narrow applications, their centuries beat our months. This is not nostalgia. This is data. The Roman method produced more uniform nanoparticles in the specific size range needed for dichroic effects. The science is clear. When Roman glassmakers combined gold and silver at high temperatures with trace metals, the precious metals dissolved into the molten glass. As the glass cooled, atoms of gold and silver found each other, clustering into particles exactly large enough to interact with visible light, but too small to be seen. The trace metals acted as nucleation sites, controlling where and how these clusters formed. The craftsmen did not understand quantum physics. But they understood that this specific recipe, fired at this specific temperature, for this specific duration, produced glass that glowed like fire when held to a lamp. They knew what worked. They did not need to know why. And here is the revelation that changes everything. Pause, this was intentional. The cup was designed to be used at Roman banquets, where it would be filled with wine and held before oil lamps. The red glow through the glass would make ordinary wine appear to glow like liquid rubies. This was luxury technology, created to impress the wealthy. The nanotechnology was not an accident. It was the whole point. Today, researchers at institutions worldwide study the Lycurgus Cup not as a curiosity but as a blueprint. In 2012, scientists demonstrated that similar nanoparticle-embedded glass could detect different liquids based on color change. Water produced one color. Oil another. Salt solutions yet another. Medical researchers realized this could revolutionize diagnostics. A single drop of blood in a nanoparticle vessel could potentially indicate different diseases based on color alone. No expensive equipment. No laboratory. Just ancient Roman technology applied to modern problems. The cup that once impressed Roman aristocrats may someday save lives in remote villages with no electricity. But perhaps the most important lesson is philosophical. We lost this technology for 16 centuries. Not because it was secret. Because we stopped valuing what could not be explained. The Romans did not need theory. They had practice. And sometimes, practice captures truths that theory misses entirely. The Lycurgus Cup reminds us that knowledge can flow backward as well as forward. There is one final mystery worth considering. The Lycurgus Cup is the only intact example of this technology from the ancient world. A few fragments exist, suggesting there were once more. But where did they go? Some historians believe the technique died with the fall of Rome. When the empire collapsed, the trade networks that supplied gold and silver to specialized workshops collapsed too. Apprenticeships ended. Recipes were lost. Within a generation, no one remembered how to make glass that changed color. Others suggest that cups were deliberately destroyed during religious transitions, their seemingly magical properties viewed with suspicion by Christian authorities. We may never know. But here is what we do know. Pause, somewhere in the 4th century, a craftsman whose name is lost to history created an object so advanced that we could not explain it until 1990. He worked by firelight with bronze tools, adding pinches of precious metals according to recipes older than memory. He did not know about electrons or wavelengths or plasmon resonance. He simply knew what worked. And that ancient craftsman achieved something remarkable. Not despite his limitations, but perhaps because of them. Without the distraction of theory, he focused entirely on results. Without the pressure of quarterly reports, he could spend years perfecting a single technique. Without our assumption that newer is always better, he built on the accumulated wisdom of generations who came before. The Lycurgus Cup is more than a beautiful artifact. It is proof that human ingenuity